So in this video we're going to look at coordinate geometry part 1, and in this tutorial I'm going to be going through how to find the gradient between 2 points. I'll go through how the formula is derived and common questions that you'll be asked at this level. So before we get started on talking about the gradient between two coordinates, let's just go through some of the basics. So the gradient is a measure of steepness of a line or between 2 points. So the bigger the value digit, the steeper the line, and a positive value represents an incline, or what we call a positive gradient, and a negative value represents a decline or a negative gradient. So back in the days when you would have done this from a graph, what you would have done, or what your teacher may have suggested that you do, is, so for example, if I was asked to work out the gradient of this line here, then what I would do is I'd pick two coordinates, let's say there, any two coordinates. I would draw a right angle triangle, and then I would measure the height and the base of that triangle, where the gradient would be equal to the vertical distance divided by the horizontal distance, and obviously using a bit of common sense as to what the sign of that line is going to be. Now what we're now going to do is we're now going to be using algebra to summarize that notation. So the good thing that you need to be aware of is the fact that what you've been taught in your early years is not gone to waste, but all we're going to do now is just give it some form of algebraic notation. So it might be easier if I just rub those things out. So if I take those two coordinates, now we don't know what those two coordinates are, and like I said, if the axes were labelled with numbers, then I could easily work out the gradient by using the method I've just shown. So let's just summarise and say that this point here is represented as x1, y1, and this coordinate here is our second coordinate, so we're just going to simplify to substitute that as x2 and y2. And what that then means is that this value here is going to be x1, and this value here is going to be y1, and this value here is going to be y2, and this value here is going to be x2. So if I then go back and draw my triangle from those said points, so if I just draw my triangle there, now the height of this triangle is going to be the difference between the two y-ordinates, so this is going to be y2 minus y1, and this distance here, the base of the triangle, is going to be the difference between the x-ordinates, that's going to be x2 minus x1. So here, what we've then found is that the formula for working out the gradient between 2 points, so the formula of the gradient between 2 points is going to be equal to, now in algebraic terms, or in terms of A level, we're going to call the gradient m. Now if you think back to when you did y equals mx plus c, where the m represents the gradient, so here m is going to equal the difference in the y-units, that's y2 minus y1 over x2 minus x1, and that is certainly a formula that you would need to remember, like so. And now what we're going to do is let's have a look at some questions where we could use this particular formula. So moving on to these two examples, so I've kind of mixed these two examples up with the use of negative numbers, because that always seems to be a little bit more challenging. So here, let's have a look. So let's first of all start by writing what the formula is. Now, a common error that a lot of people go wrong when dealing with these questions is they get the numerator and the denominator the wrong way around. Now, and one of the common misconceptions is the fact that because coordinates are written as xy, students always tend to write x2 minus x1 and y2 minus y1, or they'd get the two things here muddled up. Now, the difference, if you were to get these two numbers muddled up, what that will have an effect on is the sign of your gradient, and obviously it has a massive impact if you don't know the actual points of where if you can't visualize where the coordinates are in relation to the graph. So there is no need for you to draw a graph, although it's very good practice for you to have some form of idea as to what the coordinates are going to be placed in. So for example, I've got the coordinates 2, 4 and 5, 8. So here they're all in the first quadrant. So 2, 4 I'm going to say is going to be 2 across, 4 up is going to be about there, and 5 across, which is further to the right, and 8 up is going to be here. So as you can see, I'm going to end up with a positive gradient. So looking at A, all we're going to do here is substitute the numbers in. So this is my second coordinate, and this is my first coordinate. So the purple or the pink highlighted is going to be, let's say, my y2, y1. Don't know what's going on there. There we are. Right, so here we've got m equals, and it's going to be 8 minus 4 over, and it's going to be 5 minus 2. Now, one way of recognizing how I always say to make sure that this is correct is if I look at, if I just get a different color highlighter, let's go for green. So if I just look at the first column of numbers, 8, 5 or 5, 8 going upwards, you can see that that represents this coordinate here. And if I, let's say, look at the second column, so this column here, then as you can see, that represents that coordinate there. So it kind of falls in line in terms of the coordinates. And again, it's always worth making sure that you don't do that, so let's get that back up, of making sure that your coordinates are written in the correct manner. So all I then need to do is simplify that. So 8 take away 4 is 4, 5 take away 2 is 3, and then that is my final gradient. So there we've got a gradient of 4, 3. And what I'd recommend that you do is leave it as a fraction. Okay, try not to write it as a recurring decimal. I would just shy away from using decimals. At this level, try and work with fractions. So moving on to question B. So here we've got our y2, which in this case is 3, minus 5 over, and then we've got minus 7 minus 3. So here we've got two minuses, so that becomes 8. And then we've got minus 7 minus 3, which is minus 10, which then simplifies to be minus 4/5. Now, it doesn't really matter where your negative goes, whether it's on the numerator, on the denominator, or just in the middle, then that there is our final answer. So just be careful with the signs, and you'll be absolutely fine from there. Now, another type of question you could get asked is what we call like reverse questions. So in this particular question, we are given what the gradient is, which in this case is minus 4, and we need to work out what part of the coordinates are. So again, just making a quick note of the gradient formula. And again, the more times you write it, the easier it'll just become instinctive to you to familiarize yourself for that. So here I'm going to have this as my second coordinate, and this as my first coordinate. It doesn't really matter which one you go for, but again, as long as you've got the coordinates in rows, that's going to be fine. So your first coordinate is on the right hand side, your second coordinate is on the left hand side of your sort of formula. So here what I've got is I've got 4 minus 8 over, and it's going to be x minus 2, and that all equals minus 4. Now I can simplify this as minus 4 over x minus 2, and I'm going to put that in brackets, and by putting it in brackets it should give you a clear indication about what we're going to do next. So what I'm going to do is I'm going to take the x minus 2 over to the other side, so I've got minus 4 equals minus 4 x minus 2, expand the brackets out in which I get x minus 4x plus 8, take the 8 over to the other side, so I get minus 12 equals minus 4x, and so therefore x equals positive 3. Now I hope that makes sense in terms of how we use the form, or how we derive the formula for working out the gradient between two coordinates and going through some examples. I'll be honest, this is a small part of a bigger picture. So although these questions might seem a little bit simple, or you may have come across this method before, the questions tend to be more merged together with other subtopics of coordinate geometry. So as well as being able to work out the gradient to two coordinates, it's also massively important you're able to work out the gradient looking at the equation of a line. Now if we go back to basics, the usual format of the equation of a straight line is usually in the format of y equals mx plus c. Now where m is the gradient as a letter that we still use to this date. So here our m value is the gradient and it's the coefficient of x. Now when you're reading the gradient of a straight line, it is massively important that you remember one key fact, and that key fact is that the gradient of a line, to read the gradient of a straight line, it's always going to be the coefficient of x when y is the subject. So if I just get rid of that and go from here, so the most important thing from this is this bit here, is that y is the subject. So before you attempt to work out the gradient of any line, always check this one thing, is make sure y is the subject. So if we have a look at some examples now, so let me just scroll down to some questions. So here we've got a range of questions looking in a range of different formats to how our equation is written. So if we look at question A, so for this, the first checkpoint is y the subject, which it is. So in question A, it's just the coefficient of x, which in this case is 5. Looking at equation B, so again I asked myself, is the equation, has it got y the subject? Yes it has. So I'm looking at the coefficient of x, and in this particular case my coefficient of x is -3. So it's important that we don't ignore the sign of our gradient, so this would represent a line that's going diagonally down. Then for C, as you can see here, what's my coefficient of x? Well, there isn't, so the gradient there is 0. For D, now as you can see with regards to D, y is not the subject. So what I need to do, if I just write out the equation again, is I need to make y the subject. How do I do that? Well, I divide both sides by 2. So what I end up with is y equals 4 divided by 2 is 2x. 13 divided by 2, I'm going to leave as a fraction. So here, now that I've got y the subject, I can read off the coefficient of x. So here my m value is going to be 2. With E, and again here, as you can see, I've got 3x minus 4y equals -3. And what I need to do is rearrange the formulae to make y the subject. So I've got minus 4y equals -3 minus 3x. And then I'm going to divide both sides by -4. And there we go. So here I've got y equals, and it'll be plus 3 over 4 plus 3 over 4x. So my m value in equation E is going to be 3 over 4. And note how the fact that I've kept it as a fraction so that I don't have to worry about working with decimals. So moving on to our last example, which is F. Again, what I need to do here is rearrange it so I've got x the subject. So with F, I've got 4x plus 7y plus 3 equals 0. So I'm going to take everything I don't want over to the side. So I've got 7y equals minus 4x minus 3. And then divide everything by 7, in which I get minus 4 over 7x minus 3 over 7. And then all I've then got to do is read off the coefficient of x, which in this case is minus 4 over 7. So here I've got m equals minus 4 over 7. So as I said, it's massively important that you're able to first have these little signs, these triggers, before you're attempting these questions. So your trigger here would be, the very first thing you think about is, have I got y the subject? And once you've got that subject, and if you haven't, rearrange it so that you have. And then to find the gradient, it's just a case of reading off the coefficient of x, making a special note of if there is any negative signs involved. Like I said, hopefully this makes sense to you. It will be used more when we look at equations of a line. And if you have any questions or would like a worksheet on this, feel free to drop an email to 162maths@gmail.com.